Myself Marunisha. I am from group 324 and today my topic is propagation of nerve impulse. So simply electrochemical processes that are similar to the movement of nerve impulse. For example, such a process occurs when a pure iron wire is immersed in concentrated nitric acid. The wire surface becomes coated with a passivating oxide film. If the film is destroyed at some spot, the iron will vigorously dissolve. This process spreads along the wire. The activation front advances, this being followed by the repassivation of the iron. This is the model thoroughly studied by Lilly and also by Marking. The theory shows that there is a far-reaching formal analogy between the Lilly model and the model of propagation of nerve impulse. Other models have also been developed. Nerve excitation begins with a local generation of action potential. The impulse then propagates along the nerve axons and synapsia, which are systems composed of numerous fibers, the impulse passing from one fiber to another. The essential structure is characteristic of smooth muscle which coat the hollow organs of animals. Nerve excitation is transmitted from one neuron to another by means of synaptic transmission. The nature of which is a special problem. Before we consider the generation of nerve impulse determined by physiochemical processes in an active membrane, let us turn to a physical treatment of the propagation of nerve impulse, especially important in the field of works by Hodgkin and Huxley, which are devoted to the solution of the entire problem. Theoretical calculations of the shape of action potential and the speed at which the nerve impulse is transmitted. The basic equation for the membrane current that arises in a homogeneous portion in response to a shift in potential may be written in the form of current is equal to C d phi by dt plus I, where phi is the potential difference between two sides of the axon membrane. C phi is the capacitive current associated with a change in the density of ions on the external and internal surface of the membrane, and IE is the ionic current determined by the movement of charged particles across the membrane. For the squared axon, IE is composed of the currents of N, sodium and potassium, and the leak current IY. Hodgkin and Huxley have demonstrated experimentally that these ionic currents are linearly dependent on the corresponding electrochemical potentials, that is INA is equal to GNA phi minus phi NA. The Hodgkin-Huxley theory is based on the separate measurement of the potassium and sodium current. To do this, the voltage technique is used. Let us make use of models showing by short circuiting the membrane with a metallic wire, we can sharply lower the membrane potential down to zero. The capacitor C is charged after which current is created only by ions that pass through Rn and Rk. Thank you.